In this question, there is a system shown in the figure. If this 5 kilogram was left from rest, okay, initially this 2 kilogram is in contact. Now what happens? This I have to read it again. A system is shown in this figure is released from rest with a mass of 2 kilogram in contact with the ground. Up here you have ground. Okay, so there is no friction. So leave it. So speed of the 5 kilogram block when 2 kilogram block leaves the contact. When it leaves the contact, what is the velocity of the 5 kilogram block? That is the question is. So here when it is leaving the contact means what? Your force which is acting downward is 2g. Okay, if this tension is equal to 2g, then net force here will become 0, then it is lifted. Okay, then who is going to provide the tension here? Here if I leave this block, so this will go up by some distance x. Because of that here some expansion will happen. Okay, because of that this spring will pull it down. Okay, your spring force is going to provide that tension. Okay, that spring force is pulling this up. When it is lifted means what I can say, T, which is nothing but 2g. Here this tension is nothing but your spring force. Spring force will be equal to what? Kx, simply Kx. X is the expansion happened. Kx should be equal to 2g. How much expansion happened? So 2g by k. So this is 20 divided by k, here given as 40. Which is 40, which is 1 by 2. Now what is the velocity when it is here? We have to apply energy conservation. So when the 5 kilogram is here, it goes down. Your potential energy lost, okay, by 5 kilogram will be equal to what? When it goes down, spring potential energy increases. So it is nothing but potential energy of the spring plus when it comes here, kinetic energy of 5 kilogram. This is how energy conservation will take place, because this is just lifted, this is not moving with any velocity, so no kinetic energy will be there. Potential energy lost is what? Mg, this distance is x, mgx. Mgx will be equal to half kx square plus kinetic energy will be equal to half mv square. So we can apply this. So here mass is 5 kilogram, g is 10, so x is 1 by 2, which is equal to 1 by 2, here again 1 by 4, ki is half kx square. So into k is 40 plus half m is 5, v square we have to find. So here if you check this, I will get 5, so I will get 25, which is equal to, cut it, you will get 10, again cut it, you will get 5. So 5 plus 5 v square by 2. So here 20, which is equal to 5 by 2 v square we are getting. If you cut it, 5 4s are 20. Here your v square will be equal to what? 2 into 4. V which is equal to 2 root 2. Okay, so 2 root 2 meter per second. Option B is correct.